Uh, Unit 3.5 is just that, the application of Newton's laws, mainly, again, dealing with friction, because that is still something that needs to be talked about, and it's not just going to be friction in one direction. We're going to talk about friction at an angle. So our vector our understanding of vectors needs to also be used and utilized as well. And if some cases it might all of a sudden make Unit 3 and just Newton's laws a little bit more applicable, because now we can talk about the other stuff that's going on, and it might make more sense. Kind of, you're getting a better understanding of the whole picture with that. And I think that's where this becomes a thing, and we split it up because, again, it can be a lot to deal with. If we added friction right on top of the last unit, I think it would be too much. So, maintaining to understand some of the misconceptions about force. Some of them I hope that we don't still have, and that is when an object is thrown, the force of the hand remains on it. That would be false. Once there is no contact, the force is no longer there. I think I use baseball as an example of this, is that once the pitch is thrown, there's very little the pitcher can do anymore to affect it. The grip to attempt to throw a curveball or a slider is, once you've let go, you're kind of banking on that grip to do, and the spin that you put on the ball, the forces that you had initially added to the ball, or you're just praying that it takes into effect. Sometimes it does, and it does what it's supposed to do. Sometimes it doesn't, and it goes straight or right at somebody, or wild pitch, or whatever it may be. And that's where things, okay, where did it go wrong? And that's where I think we have to kind of step back and go, okay, where did it go wrong? It's usually somewhere at the beginning, not, well, the air current just didn't quite take it the right way. No. That might seem like a reasonable answer, but it's it started probably farther back. Inertia is kind of the product of the environment. It is not a property of the object. The object's mass is a product of its properties, not a force in itself. Now, the third one is the toughest, I think, and that is mass times acceleration is a force, and it's not really, we kind of use it that a force is equal to, that they are, both sides are equal. It's a kind of a proof. It's kind of the end result of a proof, an experimental proof. That if you have a force on an object, it's going to accelerate in the direction of said force. And that's what gives us that equation, and that it's not a force in itself. It is a proof of Newton's, essentially the proof of Newton's second law. Air does not exert a force. Well, that's completely false. because air exerts a huge force. Stick your hand out of a car when it's going 50 miles an hour on a nice day, not when it's cold outside. Okay, you can do that this morning when it was negative 16. Might freeze your hand a little bit. Okay? But on a nice day, stick your hand out, and all of a sudden that hand's gonna zip up and down in every which way. They really frown upon sticking your hands out of cars now, but I remember back when I was growing up, you could stick your hands out of cars. You could stick your head out of a car, for crying out loud. But you just kind of do like the air currents, and you just kind of learn what the Wright brothers figured out. Kind of how you hold your hand is going to change the lift that you get as you're moving. And so it's that huge force that we see. Now, air resistance can be calculated, and the force of air resistance is equal to the velocity times the area. And so we have a little in the area. We have to be careful that that's a capital A, not a lowercase a. In there as well. Forces needed to keep an object moving. We should know that that's not true. Is that if an object is no other forces acting on it, it will continue. But because friction is such a major factor, it's very, very difficult to get rid of. And in many cases, we have to account for it. And that's what we start to do in this unit, is account for friction through calculations and computations.